Hello everybody. Welcome to creating the basic adaptable game engine library, part 5, vector class code. In the last video, we talked about the structure of the vector class and we looked at some of the Java doc. In particular, we know what fields it's going to have and what methods we need to implement. In this video, we're going to go ahead and implement those methods. It will also draw upon some of the mathematics we talked about a few videos ago, so hopefully you have some of that committed to memory. As I mentioned, I think earlier in the video series, I'm going to be using a development environment called IntelliJ, which you can download for free, and you can use that environment if you want, or you can use any other software you're comfortable with. I'm not going to present a tutorial on how to use IntelliJ because their website already has that information. So let's go ahead and head on over to IntelliJ. Now, I've started a brand new project called Bagel Java Tutorial since I'm showing you how to create the Bagel project in Java. And I use the default template, which creates a command line application. Kind of gives you this code automatically, but I'm not going to need this class, so I'm going to go ahead and right-click and delete it from the tree. Instead, we're going to create a new class, and this class will be called Vector. And I'll make that a little bit larger. All right, and in this class, I'm not going to fully document it because that would take a long time and it might be a little bit boring to watch. However, I will be posting the complete commented source code online at GitHub, and hopefully the link will appear somewhere down below in the description. All right, so the class is called Vector. It's got two pieces of information that we need. It's going to store a double x and a double named y. There's going to be two constructors we mentioned, one that initializes the vector to 0, 0, and the other allows you to submit the initial values. But first, I think before we create that, to minimize redundant code, let's create a public void set values, which takes as inputs double x and double y. And here, I'm going to use this notation to minimize confusion. All right, so it's going to set the x and y belonging to the class to the values of the parameters x and y. And this function will be super useful in the constructors. So I'll create a first constructor, public vector. And by default, that will set the values to 0, 0. And IntelliJ does all sorts of good things, like it'll tell us what the names of the parameters that we're setting on. It's really cool. All right, let's also set up a parameterized constructor. So this will take double x and double y, and it will set the values to be, well, x and y. All right, the class is coming along pretty well. Next, for combining vectors, right, if we wanted to add a vector to a point, for instance, remember vectors and points are both going to be handled by this class. We're going to have some add methods, and the add methods will change the values in this instance of the class. So let's create public void add vector, and this will take in another vector. So maybe the other vector is called other. We'll take this dot x and we'll add the other vector's x. Similarly, we'd like to add something to y. So this dot y plus equals other dot y. That'll allow us to add another vector to this one. It'll be really useful when we talk about physics and velocity and how velocity changes the position of an object. Let's also create a method called addValues. And this will take in two parameters, a double dx and a double dy. And we'll say this dot x plus equals dx, and this dot y plus equals dy. All right? And those are some of our vector addition operations. The other mathematical operation we're going to make quite a lot of use of is scalar multiplication. It's when we multiply both parts of this vector by a constant. I'll just call that public void multiply. All right. And this will be this dot x times equals the scalar. It's interesting they call it scalar multiplication. Right? The idea is you're multiplying both numbers by this constant. The effect is to scale the vector. Either you're stretching it out or you're shrinking it down. Those are both called scaling operations. All right, there's our multiply function. And now we get to do some of the methods which involve length and angles. And first, let's set up a public double get length. Right, in this case, what we need to do is use the Pythagorean theorem. And so we're going to return math dot square root of this dot x times this dot x plus this dot y times this dot y. All right? And again, this is like the square root of x squared plus y squared. So that'll tell us how long this vector is. All right. While we're talking about length, maybe we'll do the set length method as well. Right, and this is kind of an interesting one. This is public void set length. And because we want to be careful that we're not going to change the current angle of, or the current direction of this vector. And that's a little bit complicated. So actually, before I do set length, I probably have to do get angle first. All right, so public void, let's do public void get angle. Actually, that's not void at all, right? That's going to be returning a number. That'll be public double get angle. All right, so this is going to return, we're going to use math.atan2. Right, there's two versions of the arctangent function. This one takes both the x and the y values. The reason it's important to have two versions of the tangent function, just the regular arctangent function, it's arctangent of y over x, and that fraction, there could be some cancellation of negatives, and it might give you the wrong quadrant for your angle. So this is going to be the value that we're going to return, but wait, we're not done. Two things we want to keep in mind. Are we using radian measure or degree measure? And this is something important to add into the comments. Right? Even though math functions use radian measure, I think a lot of people think in terms of degrees. So what I'd like to do is say, create a convention where the get and set methods will accept degree measurements and return degree measurements. So just as a note, this returns degrees, or angles in degrees. And to do that, I can say math.toDegrees. And so this will take the angle measure, which is returned. Right? Math.atan2 returns some value in radians, and then this function will convert it to degrees. For those of you who really like math, this is just multiplying by 180 divided by math.pi. Right? It's multiplying by a factor to convert. But this code, I think, reads a lot better. It's converting it to degrees. All right, very cool. Now we want to do set length. Right? So in this case, what do we need to do? First, we need to get the angle, and then we're going to convert that angle to radians. So let's see. First, let's say double angle degrees is going to be get angle. And now I'm going to convert that to radians. Right, so let's say not public, what do I want to do? Let's say double angle rad is equal to math.2 radians. This will be angle degree. Right, I need to do this conversion at this point because all the math functions, the Java math functions, require radian output. Right, so I've got angle rad. And then what I need to do is change the values of this dot x and this dot y. Right, so you might remember from before that the ways we can calculate the x and the y values, there are some mathematical formulas there. The x value can be calculated as the length of the vector times the cosine of the angle. And so set length, this should really have some parameter, whatever we want the length to be. And the x value, the adjacent side, can be calculated as length times math.cos of the angle in radians. All right, and to calculate the y component, the length of the opposite side, again, that's the length, or the hypotenuse, times math.sine. And again, the math class functions want their angle measurements in radians. All right, so hopefully that makes sense. Right? If you want to change the length of a vector, right, the length is going to be, well, first store the angle, and then use our formulas to calculate x and y in terms of the length and the angles. All right, and setting the angle is going to be kind of a similar process. Right, so when we set the angle, whatever we want the new angle to be, and let's assume it's in terms of degrees. Right, we first need to know what the current length is, and then we will, let's see, convert the degrees to radians. So let's see, double length is equal to get the length. Right, that's not going to change. And double angle radians, angle rad, is equal to math.2 radians. All right, and then we're going to use precisely the same formulas we did before. And just copy and paste those down here. Right, in order to figure out the x and the y values, right, the lengths of those two sides of the triangle, we just need length times cosine and sine of whatever the angle is. Right, these formulas stay the same. The only thing that's different between these two set functions is which information are you given. Right? So in this case, you're given a length. In this case, you're given an angle. Either way, the mathematics stays the same. Cool. All right, so we've got get length, get angle, set length, and set angle. And so I think all of that looks pretty good. Oh, wait, I don't want to go back here yet. There's a couple more functions that we're going to need, right? In order to actually see if these vector equations look correct, we're going to test this class in the next video. But I need to be able to print what these vectors look like. So I'm going to create a method called toString. Right, and this is something which we're overriding. Right, in here, I think this notation indicates that we're overriding a pre-existing method. So what I'm going to do is return, let's make this say, use angle brackets, plus this dot x, plus a comma, plus this dot y, plus another angle bracket. And this will allow us to visually inspect the contents of the vector. right? We'll be able to print these with a system.out.print. Very good. That seemed surprisingly fast. That was a lot of methods we wrote really quickly, right? The really tricky ones, I think, are set length and set angle. We have get length and get angle. I think that's just about everything. All right. The other thing we should probably pay attention to here in get angle is what if both of these values are 0? Right? If your vector is 0, 0, if your vector is effectively just a point, what should the return value be? And so we should probably add this in as a special case. If get length is 0, then we should probably return the default angle, which will be 0. In other words, we'll say the 0 vector by default has an angle of 0 with the x-axis. The 0 vector points to the right. Else, we'll return this value here. All right, that's all the code that we're going to need. I'm going to go ahead and add some comments to this, and then I'll upload this to GitHub. And in the next video, we're going to test this class by creating some vectors and calling these different methods to make sure they return the values we're expecting. But that's enough for this video. Thanks for watching, and I'll see you in the next video.